welcome students to the first section now of the first chapter in NCERT 9th standard mathematics, and here we are looking at natural numbers. We are looking at what is so natural about natural numbers. So or why do you call natural numbers as such? Now suppose we have one box and we are denoting it by a single line. Naturally, for two boxes, we'll be denoting it by two lines, or three boxes, three lines, going on like that. Of course, we can't go on like that. It will be very tedious, but just for the case of discussion, let's stop at three boxes. So three boxes would be represented by three lines. Now, a key and important thing about this is that you are seeing something, and then you are denoting, or you are writing something which is dealing with how many of those things you have seen. So not that point. You are seeing something, and you are simply writing something which indicates how many of those things you have seen. So not the point that the image which you got, or the image which you have understood is being transferred to a particular image which deals with how many of those objects you are dealing with. So a image of something becomes a symbol of or another image which represents its number or its count. So that means one box by one line, two boxes by two lines, three boxes by three lines. Of course, if the number of boxes increases to a huge extent, this will be extremely tedious and time consuming. But for the sake of discussion, we are looking at to understand the key idea. So all this means natural numbers denoted by capital N would basically be the first numbers any human being would be encountering in his or her life. So that's a key point. Because when we see objects of the same kind, multiples of objects of the same kind, will be cooking up an image or cooking up a symbol to represent how many of them are there, and that's one of the key things which actually enables us to enter the world of numbers. So moreover, a very important point is that these objects are very distinct. That means boxes means that one box and the other box would be having similar properties. So not that point. So as I already told, the first elements are represented by these numbers, and another related interesting point is that we can represent these distinct objects also by using the fingers of both our hands. Of course, that can go only up to 10, but the meaning is that it's once again the beginning of our entry into the world of numbers. So using the fingers of both of our hands, we can represent multiples of distinct objects. The only thing is that we can do it only up to 10. So for more than 10, of course, you will have to repeat the cycle here to start with one of the fingers once again. So all this, so what does all this mean? It means that natural numbers or counting numbers, which is denoted by capital N, represent the first numbers which any human being would be noting, or any encountering at the beginning. So not that point. So N represents the numbers any humans would naturally encounter. So naturally encounter is a key point here, and that is exactly why such numbers are called natural numbers. And of course, not the point that natural numbers start with 1, goes on like that, and there's no ending to the natural numbers. So it's infinite in the sense that if we call a particular, or if you denote a particular natural number as the end of the set, then we can simply add on to it, which is something like n going on to n plus n plus 1. So there's no end to the set of natural numbers. Now let's look at some of the interesting properties of natural numbers. The first property we are looking at is what is called the closure property. So what exactly is the meaning of closure property? Closure property means that when we do a particular mathematical calculation, the result we get is the element which is the result we are getting belongs to the same set. That's the thing which we are looking at. So first we are looking at the property of addition. So a plus b, if a and b belongs to the set of natural numbers, the elements of the set of natural numbers, then for all a and b, they belong to the set of natural numbers, which means that addition, the mathematical operation of addition comes under, is followed as far as closure property is concerned. Same is quite the case with multiplication. In multiplication also, when we multiply two elements which belongs to the set of natural numbers, the resulting element also belongs to the set of natural numbers. Very simple examples. 2 times 3 gives 6, and 6 of course is a element belonging to the set of natural numbers. 25 times 25, that is 25 squared, gives 625. Of course 625 also belongs to the set of natural numbers. But if you look at subtraction, that's not the case, because a simple example, 5 minus 7 gives minus 2. Of course minus 2 that number doesn't come under the set of natural numbers. Same is the case with division. Division also doesn't come under the closure property, because for example, 18 divided by 6, of course we know that it's 3, and 3 of course comes under the 3 is an element of the set of natural numbers. But what about 10 divided by 3? It's 3.33, which if we know that it's a decimal number, and decimal numbers doesn't come under the set of natural numbers. So as far as closure property is concerned, only multiplication and addition comes under, follows the rule of the closure property. Now let's look at this property in a different manner to get a better idea. So here is a number line. Note that this number line denotes the set of natural numbers. Of course that means that the first number would be 1. And we can see that why addition and multiplication are following the set of natural numbers. This is because both are actually adding on to the number line, in the sense that we are going further to the positive direction of the number line. So in both the cases. And it's exactly because of this, both addition and multiplication, the elements come under the set of natural numbers. And to get a better example, multiplication is actually addition in a multiplicative format, in the sense that if 2 times 3, of course that's 6. That also means it's 2 times 3, or something like 2, the digit 2 is added 3 times, that is 2 plus 2 plus 2. So we can easily see that multiplication is a form of addition, and which means that the element which is got by multiplication of natural numbers would be furthering on to the number line which we have described here, which also means that multiplication, the element got by multiplication, would naturally be naturally belong to the set of natural numbers. Now we are looking at the associative property, and how associative property is dealing with the whether it works for the set of natural numbers. So associative property basically means how you are adding three elements. So first, a plus and b plus c together added, it's equal to a plus b added first, that's put in brackets, then we are adding c. So we can see that in the case of associative property also, both addition and multiplication, it's possible for the set of natural numbers as far as this property is concerned. That is, a times b times c done first is equal to a times b done first. So that's why it's put in brackets times c. So we can see that for multiplication as well as addition is concerned, associative property works. We can take a basic, very simple examples to get the point across. For example, 9 plus 10 plus 2 is also equal to, is equal to 9 plus 10 done first because it's in brackets plus 2. Same is the case with 9 times 10 times 2 done first, and that is equal to 9 times 10, which is done first because it's in bracket times 2. So 10 times 2 is 20. 9 times 20 is of course equal to 90 times 2, which we know that the answer is 180. And 180 of course belongs to the set of natural numbers. So associative property, as far as the set of natural numbers is concerned, it works for both addition as well as multiplication, but for subtraction and division, as we have already seen in the case of the closure property, the associative property also doesn't work. A simple example, for example, for getting a better idea, 7 minus 5 minus 3 in brackets is not equal to 7 minus 5 in brackets minus 3, because 7 minus 2, we know it's 5, and 2 minus 3 is minus 1, and we know that those are simply not equal. It's similar is the case with 9 divided by 2 divided by 9 divided by 3, which is not equal to 2 divided by 9 the whole divided by 3. So it will be 2 divided by 3. In the first case, we will be getting a recurring number, that is 0.6 bar, and in the other case we will be getting, interestingly, another recurring number, that is 0.0740 bar. So, and naturally 0.6 bar is simply not equal to 0.0740 bar. So we can see that that's the case with subtraction and division. Now let's look at the third property, and whether it works for the set of natural numbers, that is the commutative property. And the commutative property basically means that as far as addition and multiplication is concerned, this property works. And let's look at but for the case of subtraction and division, this property basically doesn't work. So first let's look at the case of addition and multiplication. Commutative property basically means a plus b should be equal to b plus a, where a and b are elements of the set of natural numbers, and we know that 3 plus 4 obviously is equal to 4 plus 3. Same is the case where 3 times 4 is equal to 4 times 3. So you can see that the order in which the multiplication is carried out doesn't alter the result. So that's the key point. So a plus a into a times b is equal to b times a. Now let's look at whether the same thing is happening for subtraction and division. And we can look at quite simple examples. Is 3 minus 4 equal to 4 minus 3? Obviously it's not equal, because 3 minus 4 obviously is minus 1. The other thing is 1, and minus 1 doesn't belong to the set of natural numbers. Distributive property. So all these properties, students may feel that it's quite simple, it can be neglected, but do remember that they play a very important role when we go to the higher applications in mathematics. So looking at distributive property, 8 times b plus c, which is done first, or 8 times b plus c in brackets is equal to ab plus ac, where a, b and c all of them are elements of the set of natural numbers, and 8 times b minus c in brackets is equal to ab minus ac,